Good morning to everyone. First of all, we are going to discuss a case study on the subject irrigation and drainage engineering. So, on that, a case study on soil moisture measurement is included here. So, what is an idea about soil moisture measurement? What is mean by soil moisture measurements? Which means the quantity of the moisture and the amount of the moisture which is available in the soil, and how we are measuring, and what are the equipments and instruments which is used to measure the moisture which is available in the soil. This is what the case study we are going to discuss about. Okay, so so first thing is about gravimetric method. This is actually an ancient method which is used to measure the soil moisture content which is available in the soil, and this method involves collecting the soil sample from the field using auger and determining its moisture and dryness. So that we have studied this all these things in the soil mechanics subject, and also it is experimentally done in the soil moisture. Soil mechanics lab itself. So we all know that auger. So the auger will pick up the soil sample, and it is used to determine its moisture and dry weights. And the more weight is determined by weighing the soil sample, and it is at the time of sampling. And dry weight is obtained after drying the soil sample in an oven at 1 or 5 degrees Celsius for 24 hours. This is all about the gravimetric method. And this method is the ancient method. It is used in villages to determine the moisture which is available in the soil in the agricultural fields. And the after finding the weight loss represents the soil water, the quantity of the moisture which is available in the soil is being measured, and finally, which is the answer, the solution is being found out with the help of the formula called theta m is equal to mu, m mu w by ns. That is the formula. Okay. And next is the volumetric method. This is the second method or after the gravimetric method. So this volumetric water content is defined as the volume of water present in the given sample of dry soil. This method involves collecting soil sample from the field using cold sampler of known volume from respective depths in the user, and then determining its moisture and drying it using this similar process, and case of volumetric content method. And here the many formulas are also used by using this volumetric method. Also can able to determine the moisture content of the soil which is available in the agricultural field. So this is most commonly used method, most commonly used one of the methods in the agricultural field in order to determine the moisture content. So the difference in wet and dry mass of soil represents amount of water in the sample is also being calculated in this method, and the moisture content is being calculated finally, and the formula is also being used here. So theta B is equal to mw by Vt minus Vt into rho W into 100, that is mass of water by volume of coal into density of water. So with the help of all these gravimetric and volumetric methods, these are the ancient methods which was used to determine the it is used to determine the soil moisture content. Some other advanced techniques and some other advanced equipments and instruments are also being used in order to determine the moisture content. So that is one is the electrical resistance blocks. So this is one of the advanced methods which is used frequently. So electrical resistance blocks consist of two electrodes. So two electrodes are being taken, and this two electrodes, they are enclosed in a block of porous material. So a porous material, any porous material is being taken, and all these two electrodes are being enclosed in a block of porous material. So the block is often made of gypsum, and this porous material block is made of gypsum and is referred to as gypsum blocks. So the gypsum block has enclosed two electrodes. Okay, so that is called as the electrical resistance blocks. So the electrodes are connected to insulated lead wires. We know that insulated wires, they are not conductive to electricity, they are insulated. So these two electrodes are being connected to the insulated lead wires and then extend up to the soil surface. It is being extended to the soil surface. And here this gypsum blocks are electrical resistance blocks with two electrodes are placed at a desired soil depth and allow the equilibrium. So those electrodes which are being attached to the gypsum blocks or electrical resistance blocks, they are being placed at some up to some depth where the moisture content is to be checked, and it is allowed to equilibrate. So resistant blocks work on the principle that water conducts electricity. So here the principle is only the water conducts electricity but not the block, so that the block is called as electrical resistance blocks. And so after that, when properly installed to some extent depth, the water suction of the porous block is in equilibrium with the soil water suction of the surrounding soil. So electrical resistance of the block is measured by a meter. So you can, in this diagram, in the diagram you can see some block is there, a meter is there, that meter will represent the measurements. Okay, so electrical resistance of the soil decreases with the increase in the water content. So that if the electrical resistance of the soil decreases, then there will be increase in the water content, the increase in the moisture content, which is available. And low resistance means 400 to 600 ounces of field capacity, and high resistance 50% to 75 tons of ohms of 13. And here, finally, soil water content is obtained with calibration curve for the same block of electron resistance against water, against known soil water content. So this is all about the electrical resistance block. Okay. And next one of the advanced technique method is neutron scattering technique. Neutron scattering method is an efficient and reliable technique for monitoring soil moisture in the field. The neutron moisture meter consists of two main components of the probe and scaler. The probe contains the source of force neutron, either mixture of American and beryllium or mixture of radium and beryllium. The scalar monitors the fluctuation of fluid or thermalized meters, which is proportional to soil water. And this is the instrument which is used to measure the moisture, soil moisture control with the help of the neutron scattering technique. And the final one is tensiometer, which you see in the lab itself. It measures the metric potential, which indicates the tenacity with which water is held by the soil. So that the tensiometer we use to observe or indicate the quantity of the moisture which is available in the soil. So after soil moisture content review, the soil moisture characteristics curve being drawn and it is required very most. And this consists of this tensiometer consists of the porous ceramic which is connected directly to a latent patch. The tensiometer is filled with water before inserting in the soil. When the tensiometer is initially placed in the soil, the water contained in the tensiometer is gently at atmospheric pressure. And here on the other hand, they are not well suited for fine texture also. So sometimes it is having some of the disadvantages, but this tensiometer is not that much suited for the fine texture. So this is the diagrammatic representation and pictorial representation of the method which is being carried out, and you can see in the right side the tensiometer is available. Thank you so much.